Welcome back. In this session, we will be discussing second lesson in class 10 chemistry, that is acids, bases and salts. So in today's session, we will be discussing the introduction of the lesson, very simple and very easy portion, and most of the questions are usually asked from this particular portion. So let's get started. Acids and bases. Now let me write a couple of substances known to you and let us discuss which of these are acids and which of these are bases. So certain substances are written, of course, just by looking at the name you can say which are acids. Hydrochloric acid and sulfuric acid are definitely acids. Let us look at these four. Curd, what we eat at home, soap which is used for washing our hands, etc. Glucose, which we drink as instant energy drinks. Alcohol consumption is not good for health. Calcium hydroxide, that is slaked lime. So how to find out whether a given substance is a acid or a base if it is not clearly evident? So for that you should know the general properties of acids and bases. If you know what their properties are, then you will know which substances are acids, which are bases. So acids in general, they have a sour taste, whereas bases, they taste bitter. But if these are acids and bases, they are of course harmful, so you cannot always taste them to find out whether they are acids or bases, because acids, these can cause burns on the skin, whereas bases are corrosive. They can cause corrosion. So because of these two reasons, you cannot touch them or you cannot taste them. Then what other way can be used to find out whether a given substance is acid or a base? So for that we can use what is called as a litmus solution or a litmus test. When we do a litmus test, if a substance is an acid, it will turn blue litmus paper to red color, whereas if it is a base, it will turn a red litmus paper to blue. Such substances, litmuses, etc., these are called as indicators. These are substances which tell us whether the given substance is acid or a base. Indicators. So litmus is one such example for an indicator. So let us say you have three substances A, B and C. One is acid, one is a base and one, let us say, is a neutral substance. So how will you find out which one is acid, which one is a base? Very simple. You say this is a test tube containing the solutions. So all you have to do is dip your litmus paper into it. So this is a blue litmus paper, this is a red. So dip both the litmus paper into the 3 given solutions. So whichever solution will change the color of the litmus paper, it will indicate the nature of the substance. For example, let us say in C we find that the blue litmus changes into red color, whereas the red litmus does not show any change in color. So we can say that this substance is a acid which turns blue into red, but red litmus does not have any effect. Whereas in B there is no change in the color of the litmus paper at all. So we can say that this is a neutral substance, and in test tube A we find that the red litmus, it shows a change in color to blue. So we can say that this substance is a base. So when substances are given to you using the help of indicators, that is litmus paper, we can tell whether the given substance is acid or a base. We also can use change in smell as a indicator. So these are called as olfactory indicators. So whenever there is a change in smell also, we can come to know whether it is acid or a base. So olfactory indicators can also be used. Other than this, we can use universal indicators such as a pH. It can be used for both acid as well as a base. That's why it's called universal. And it will also tell you whether a substance is neutral. Whereas in blue litmus and in red litmus, it is meant specifically for acids and bases. Whereas a universal indicator, it could be in the form of a solution, or it could be in the form of a pH paper which contains a mixture of different indicators. So pH paper can be used in laboratories to find whether a given substance is acid or a base. If you want to get accurate measurements, then we can use what is called as a pH meter for accurate measurements. For approximately knowing whether it is acid or a base, we can use a pH paper. So let us understand what is pH and how does it help us to identify whether a substance is a acid or a base, and what is the importance of pH in our everyday life. So before going that, let us answer this question. So now all you have to do is make their solutions of this. Curd is already in solution form. So solution you have to make. Glucose you can dissolve in any solvent, that is water, and alcohol is in solution form, and you can use blue litmus paper, red litmus paper, or pH paper to find out whether it is acid or a base. So we will know that a curd is a acidic substance, soap is a basic substance, calcium hydroxide is also a basic substance. Whereas when we dip the litmus paper or pH paper into glucose or alcohol, there will not be any change in the color. So these two are neutral solutions. So that is the importance of pH, a universal indicator. What is this pH? the letters P and H refers to power of hydrogen ion, potence hydrogen in German. P stands for potence, that is power. H stands for hydrogen ion. So that is what is pH. It will measure the amount of hydrogen ion in a solution. The question is, why is it measuring hydrogen ion? Because an acid and base, if you have to define them based on their chemical property, an acid is a substance that produces H plus hydrogen ion in a solution, whereas a base is a substance that produces OH minus ions, that is hydroxide ions in a solution. So that would be the definition of an acid or a base. Generally, acids are substances that are sour. They cause burns and they turn blue litmus into red. Chemically, an acid is a substance which, when dissolved in a solution, it produces hydrogen ions, whereas a base is a substance which produces OH minus hydroxide ions in a solution. So that would be the definition of acid and a base. That is why the pH will measure the amount of H plus ions, hydrogen ions in a solution. Two things. One, ions are produced only in solution. That means they need to be mixed with the solvent, that is water, for example. Without the solution form, they will not produce ions. And another thing is that as soon as a acid is dissolved in water, what happens? So let us say an acid such as hydrochloric acid. Hydrochloric acid plus water, we know that acid will produce H plus ions in solution. So H plus is a cation ion and it will dissociate to produce Cl minus ions. Now the hydrogen ion that is produced, it cannot stay on its own. It cannot exist independently. So what happens is, as soon as you mix a acid into a water, the hydrogen ion produced immediately it combines with water and it produces H3O plus, that is a hydronium ion, because H plus ion cannot exist independently. So when we mix a acid into a water in its solution, we find hydronium ions, and now you can balance the equation. So when you mix hydrochloric acid into water, H plus H2 will be H2O plus, and we have Cl minus. And the strength of the H plus ions will tell you about the acid and basic property of a substance. So what exactly does a pH paper, an universal indicator, measure? How will you know whether it is acid or a base? Another important thing to keep in mind while making solutions of acids and bases is always add acid to water. That is the right way to make a solution of a acid. Never add water to acid. This is because when we add water to acid, it is a highly exothermic reaction. Highly exothermic. It produces large amount of localized heat. That is, heat is produced in a very small area in the beaker or in the test tube. So the heat is so much that it could result in the acid coming out. So it could result in explosion. That is a mild explosion. The acid will come out and it could fall on your hand, eyes, face, etc. So never add water to acid, but add acid to water. How to add acid to water? Very slowly, using a dropper. We have a beaker full of water. To that we add drop by drop of the acid with continuous stirring. So that way what happens is the heat produced will be spread in the water and the temperature would be uniformly spread, so that it does not create localized heat. So always add acid to water when you are making a solution of a acid. Same goes for bases also. And adding acid to water and adding base to water are highly exothermic reactions. If you touch the external part of the beaker, it is so hot because it produces heat. So another point to remember in mind. We have pH paper, we get strips, pH strips, and they have numbers written on them. 1, 2, 3, 4, 5, 6, 7, and on the opposite side of the paper we have numbers 8, 9, 10, 11, 12, 13, 14. So if we were to have a number, a pH paper will have numbers from 0 to 14, and we have the number 7 at the center. So when we use a pH paper and dip it in a solution, if the number on the pH paper is less than 7, it is a acid, and if the number is more than 7, such substances are basic in nature. So an acid is a substance whose pH value is from 0 to 7. Bases are above 7, that is 7 to 14. The pH 7 is neutral. That is, it is neither acidic nor basic. So we can say that from 0 to 7, that is 7 is not included, 0 to 6.99 is acid. 7 is neutral, 7.01 to 14 is a basic substance. So pH, it will have different color codes. There will be a standard pH paper with particular colors. We can dip the pH paper into a solution. Whatever color we get on the pH paper, we can compare it with the standard strip and it will give us a particular number. If you want accurate number as I told you, we have to use a pH meter. Couple of important points to know about this concept of pH. So anything less than 7 is acid, anything more than 7 is a base. Solution A has a pH of 0, solution B has pH 3 on the pH paper, and solution C shows pH 6. Which among them is a strong acid and which one is a weak acid? So of course you would directly jump into the conclusion that because the number 6 is greater in value, that would be a strong acid, whereas 0 would be a weak acid. So this is what I want you to remember. As the pH number decreases, its acidicity or acidic nature will increase. So in between 0, 3 and 6, 6 will be a weak acid, whereas the solution with pH 0 will be a strong acid. What is this strong acid and weak acid? The definition of acid you are well aware of. A substance that produces hydrogen ions in a solution. So a strong acid will produce more hydrogen ions, whereas a weak acid will produce less hydrogen ions in a solution. Example for strong acid: hydrochloric acid HCl, sulfuric acid H2SO4, nitric acid HNO3. Whereas example for weak acids, we have acetic acid, that is CH3COOH, methanoic acid, that is HCOOH. So these are organic acids. Hydrochloric acid, nitric acid would be synthetic acids. So an organic acid H, so that is the group, the acidic group. So if you have a organic acid in water, when you dissolve it, so it produces CH3CO minus and H plus ions, of course. The only thing is that because it is a weak acid, the number of hydrogen ions produced is less. Therefore, it is a weak acid. Whereas in hydrochloric acid, it is HCl, the number of hydrogen ions produced is higher. So, having said that, the lesser the number, more the hydrogen ions. Whereas a pH 6 would produce less hydrogen ions. Therefore, 0 will be a strong acid, 6 will be a comparatively weak acid. Whereas on the basic side, it is reverse. As the number increases, it becomes more and more basic. So, a pH number 8 and 14, 8 will be a weak base, whereas 14 will be a strong base. So on the acidic side, lesser the pH number or pH value, it means that it produces more hydrogen ions. The hydrogen ion concentration is higher. So it is a more strong acid. Whereas on the basic side, lesser the pH number, means it produces less number of OH minus ions, therefore it is a weak base, whereas higher the pH value, it produces more number of hydroxide ions in a solution, therefore it would be a strong base. Now let us note down the bases. Bases would be sodium hydroxide, let us say potassium hydroxide, calcium hydroxide, magnesium hydroxide. Among these four, these two are strong bases, whereas these two are weak bases. Weak bases, they do not dissolve completely in water, whereas strong bases, they dissolve completely in water, and these are what are called as alkali. That is, bases which are completely soluble in water are called as alkali. Sodium hydroxide, potassium hydroxide, lithium hydroxide, etc. are examples. All group 1 metal called as the alkalis because they produce strong bases. So if you dip a pH paper into a solution of sodium hydroxide or potassium hydroxide, most probably the number would be around 13 or 14 because it's a very strong base. Whereas if you dip it into calcium hydroxide or magnesium hydroxide solution, the pH would be somewhere around 8 to 10, which is a weak base. That is the concept of pH, which is a universal indicator which tells you whether a given substance is acid, is it a neutral substance, or is it a base, going by the value on the pH paper. Let us discuss the importance of pH in our everyday life. pH from 0 to 7 is acid, above 7 is a base. The pH 7 represents a neutral solution. For example, sugar solution, salt solution, glucose, alcohol, oil, all these are examples for neutral substances. pH plays a very important role in our everyday life. For example, the pH inside the human body has a very narrow margin, that is from 7.4 to 7.8. So if the pH falls below this or above this number, it could damage the entire organs and tissue system inside the body. The pH of blood is also slightly alkaline, that is around 7.4. So that is very, very important. For example, in our stomach we have the gastric juices whose pH is from 1 to 2. These are very strong acids. We can say that they are extreme acids. The hydrochloric acid produced in the stomach, which plays a very important role in digestion of the food. But if the amount of acid in the stomach increases, then it could damage the walls of the stomach, called as acidity. Some old people, etc., they experience this. So in this case, they are given what is called as an antacid, that is against the acid. So these are, for example, like your ENO. So it is basically a mild base, mostly magnesium hydroxide. So you open this ENO packet, put it in water, dissolve, you get a basic solution. You drink it, so acid will react with the base and the base will neutralize the acid. So acid in the stomach will decrease. So That is how an antacid works. Milk of magnesia, MgOH twice. In the human body, tooth decay, the teeth that we have is made up of one of the hardest substances called as enamel, which is nothing but calcium phosphate. When we eat something during night, it contains some amount of sugar. So at night when we are sleeping, some bacteria, they will digest this sugar. For digestion of sugar, the bacteria produce some acid. This acid can eat the enamel layer of the tooth, resulting in tooth decay. Therefore, it is advised that before we go to bed, we brush our teeth, because the toothpaste, it contains basic substances. These basic substances will react with the acid produced by the bacteria, neutralize them. So, toothpastes are also, they contain basic substances. For example, the natural phenomenon acid rain. When the pH of the rainwater is less than 5.6, this acid rain, if it falls into lake, pond, river, it can damage the aquatic plants and animals. So, acid rain can also damage important historical monuments and corrode them. So, here also pH plays an important role. The pH of the soil, it plays a very crucial role in the proper growth and development of plants. Certain plants can grow only in a particular pH range. So, ideally, what farmer has to do is make a soil solution and check the pH. If it is too acidic, he can add limestone or calcium oxide to that to make it less acidic. If it is too basic, he can add some acidic substances to the soil to make it less basic. So here also it plays a very important role. So plants also require a particular pH. This pH is usually in the range of 5.6 to 6.5. So they require weakly acidic soil. So this is the range where plants show good growth. This particular pH range. Not only that, certain animals use acids as defense mechanisms. For example, when a honeybee or a wasp stings you, you feel a lot of pain. This is because they produce certain type of acids, such as methanoic acid, or ants are known to produce picric acid or myrcetic acid. There are different types of acid which causes the stinging pain sensation. So that is a defense mechanism. Even certain plants called as nettle plants, they also produce methanoic acid. So accidentally if you touch these plants, this will sting to your skin because of the acid present in them. So as you can see, pH plays a very important role in the life of human beings as well as to plants and other animals also. So to summarize this session, what we have studied: acids are substances which are sour, they cause burns to the skin, and they turn blue litmus paper into red litmus. Acids produce hydrogen ions in solution, only in the solution form, and they have a pH from 0 to 7. Whereas bases are bitter to taste, they are corrosive, they produce hydroxide ions in solution. They turn red litmus into blue, they have a pH range from 7 to 14. Those strong bases which are completely soluble in water are called as alkali. For example, sodium hydroxide, potassium hydroxide. They have a pH of around 14, whereas weak bases, magnesium hydroxide, calcium hydroxide, etc., will have a pH of around 8 to 10. So we also discussed about pH. If the pH is less than 7, it is acidic. Lesser the pH, more the hydrogen ions, more the acidic property. On the basic side, that is from 7 to 14, more the pH number, more the hydroxide ions, more the basic property. So that is about acids, bases, their general properties, and about the universal indicator, that is pH. In the next session, we will discuss about the different chemical properties of acids and bases, how they react chemically with different substances. Thank you.